Okay. Anybody want to volunteer an answer?
The line below x equals t has to be 0.
Why is that?
Because all of those points will not, in their domain of dependence, will not include the left boundary.
Right. So this is x greater than t. If I pick a point here, right, remember, as Sage is saying, the domain of dependence of this region just only encompasses the initial line, t equals 0, right? So h of t over here is only going to impact solutions above this line, right? So you can sort of draw these domain of dependence lines here to figure out when your domain of dependence is going to involve the boundary condition, okay? By the same token, if the boundary condition had been homogeneous, right? And the initial condition had had compact support in some region, right? You would need the domain of dependence of your, initial points to have, to basically, you would need the domain of dependence of solution points essentially to contain, whatever region had support in the initial condition, right? So I think we talked about this in class and in a couple of other problems, right? If the support of your initial condition is here and your boundary condition is homogeneous, right? Solutions over here would not they would be 0, right? So you'd only have non-zero solutions here, right? But that's not the problem we're looking at, right? But I just wanted to kind of expand on that idea a bit. Okay. So right, so all this region over here, right, is non-zero, right? Is 0. So u equals 0 here, and u is generically non-zero here, right? You may have points over there where u is 0, but in general it's non-zero. Okay, so let's get to the meat of the problem, right? So for part B, and I'll leave the slide up so that you can see the initial boundary value problem. I want you to solve the initial boundary value problem, okay? Assuming h of t is equal to sine of t, right? And after you do, answer the question, is the solution continuously differentiable? Okay.